Welcome to a quick tour of the evolution of mobile technology, from 5G to the future 6G, seen through the lens of 3GPP, Third Generation Partnership Project. Essentially, 3GPP is a global collaboration that sets the standards for mobile communications technology. Think of them as the architects who plan each new generation of cellular networks, ensuring that phones and networks communicate seamlessly. Let's take a look at their journey over the past decade, highlighting how they've moved from 5G to what could be 6G. Release 15, the birth of 5G. In 2018, 3GPP finalized Release 15, marking the official birth of 5G. It introduced new radio, NR, and air interface designed to provide improved speed, reliability, and flexibility. Release 15 also established a flexible architecture that supports both standalone SA and non-standalone NSA modes of operation, enabling a smooth transition from existing LTE networks. Release 16, the first 5G upgrade. Completed in mid-2020, Release 16 solidified 5G, qualifying it as an IMT 2020 technology by the International Telecommunication Union, ITU. It added support for the Industrial Internet of Things, IoT, Vehicle-to-Anything, V2X communications, and operation in unlicensed spectrum. These enhancements expanded 5G capabilities to support emerging use cases such as smart manufacturing and autonomous vehicles. Release 17, expanding 5G horizons. Completed in 2022, Release 17 further expanded the reach of 5G by introducing support for non-terrestrial networks, NTN. This enabled connectivity via satellites, extending 5G to remote and underserved areas. It also defined low-capacity, RedCap devices for cost-effective IoT applications. Release 18, the emergence of 5G Advanced. A major inflection point was represented by Release 18, completed in 2024, marking the beginning of the 5G Advanced era. This phase focused on integrating artificial intelligence, AI, machine learning, ML, into the 5G architecture to optimize use cases such as low-capacity, RedCap devices for cost-effective IoT applications. Release 19, the rise of 5G Advanced. Continuing on this path, Release 19 integrates AI ML into the NR air interface, enabling smarter beam management and positioning. It also introduces sub-band full duplex non-covering SBFD for more efficient spectrum utilization and low-power wake-up signaling, LPWS, to extend device battery life. In addition, 3GPP is conducting studies on channel modeling for integrated sensing and communication, ISAC, and the 7-tier 24 GHz spectrum. Release 20, evolution to 6G. Expected to begin in the second half of 2025, Release 20 represents a critical point of convergence, serving as the culmination of 5G Advanced and an early bridge to 6G. It will focus on a more selective set of essential enhancements to meet commercial deployment needs, while also initiating a series of 6G studies, guiding the development of 6G specifications in Release 21. As we look to the future of 6G, it is essential to consider the lessons learned from the evolution of 5G. Here are some key areas that 6G should address differently. Simplicity and scalability. Avoid overly complicated 5G designs with multiple options. Focus on technical excellence to ensure simplicity, scalability, and global adoption. Realistic performance improvements. Instead of chasing impractical performance requirements, focus on meaningful and realistic improvements that improve the overall user experience. Standalone architecture. Adopt a standalone architecture from the start to avoid the complexity and delays associated with transition modes. Integrate compute, artificial intelligence, and sensing. Rather than relying solely on bit transport, integrate compute, artificial intelligence, and sensing capabilities to enable multi-tenancy and create new value opportunities for operators. Continuous improvements. Move away from traditional release-based improvements and enable continuous improvements and innovations to keep up with the rapid pace of AI-driven advancements. In conclusion, the evolution from 5G to 6G is a journey of innovation, adaptability, and collaboration. Lessons learned from the development of 5G will guide the evolution of 6G, shaping a hyper-connected future where communications, sensing, and artificial intelligence converge to create immersive experiences.